I'm wondering if, say, you gave them a 1 or 2 to respond, make those happen.
It's a good question. So in the model there is both. So you know, you've got the sort of bound to position part of the model in that posterior system, and you've also got kind of the categorization at the level of dimensional attention. So both are running, but it is an interesting idea to say, could you take the load off the spatial part, and are there interesting predictions there? So Bruce Morton has done some really interesting work with verbal versions of the DCCS task, and essentially showed a similar developmental trajectory, but much later in development. So he finds kids aren't able to switch rules in a purely verbal version of this task until about 7 to 9 years. So that might be a way to go. And actually, the cool thing is that would get you into fMRI world too, in terms of looking at switching processes with older kids. But great suggestion. Yeah.
I wonder if you could say a little bit more about how you think the inhibitory component is working in the model. Is it just at the level of the prefrontal cortex, or is it at that?
No. So there's been a lot of really interesting debate about what inhibitory control means, and you see that beautifully in these types of models, because when I form a peak of activation, that peak actually has inhibitory consequences because it suppresses other peaks from coming up.
In the local environment?
Well, it depends. We think some systems, like motor systems, may be kind of more winner-take-all. Other systems, like the working memory system, is kind of a multi-peak thing, right? Because you hold multiple items in working memory, and so that would be a little bit more local. But you know, so working memory then has inhibitory consequences, right, at a neural level. And so what we've tried to argue is we have to be very, very careful with our words, and we have to make it clear when we talk about inhibitory control as a psychological construct, right, that doesn't mean it's implemented in the brain in terms of inhibition, right? And that's a similar point that like Yuko Mudokata has made with some of her working memory research as well. So inhibitory consequences in this model, there's a lot of them, right? Because we've got all these different coupled fields that are making local decisions, right? Each decision then has a consequence for who can pop up next, right? Or who can't pop up next. Yeah.
Is it always you're explicitly telling the child the rules going to change? Does anyone ever just take verbal out of it and suddenly the child has to understand my strategy is not working anymore, and then they have to switch?
Yeah. If you can think of it, someone's probably run it with a DCCS task. But actually that relates to some of the work I mentioned earlier that Larissa Samuelson's doing, where they actually have shown, I think if you take the label color and shape out from the instruction phase, actually 4-year-olds actually have a remarkably hard time. So the words you use definitely matter, and what our collaboration is trying to uncover is exactly how those words matter. Yeah.
That's sort of a big picture, sort of tangential to the nice details of the really nice modeling work that you've done. But you started off the talk talking about really emphasizing the strength of the DLT approach being a way of describing qualitative changes in behavior, where the child is learning something new. But then I was surprised that the rest of the talk is on executive function, which sometimes seems a canonical case of quantitative change. So I'm wondering if you can describe what you see in either the behavior of children or in the development of your parameters that you model that might be more qualitative, or
right.
do you see this as quantitative changes in the model of each child?
Right. Yeah. So great question. We one of my former students, Sammy Peroni, and I wrote what I think is a fantastic paper on qualitative and quantitative change in development. So let me give you my particular take on that issue, because it's an important theoretical question that's been around a long time, right? And I think there's been I don't want to say muddled thinking, but confused thinking about what those terms mean, right? So, for example, there's actually a really lovely paper by Karen Adolph and Scott Robinson in Psych Review on this issue, looking at timescales and sort of how you can look at a developmental phenomenon at a sort of broad scale, and it looks like there's a sudden jump in behavior, but then when you go in and zoom in at a finer grained time scale, it now appears quantitative. Okay? And in this paper, Sammy and I kind of took a stand that we think qualitative means something important. And the something important comes from dynamical systems theory, which is when a complex system goes into an attractor state, we call that, it's an attractor state. It's a particular state that we can define. And when it switches from that state to another state, there's been a qualitative change. And that's the term that dynamic systems people use. Okay? So going from one attractor state to two, even though we can count that, that's actually referred to as a qualitative change in the dynamics of the system. A new attractor state that wasn't there before has suddenly emerged. And that's the way I think about qualitative change in development, and you can actually see that in this model. So the qualitative change that happens over development in this model is actually that frontal state gets really good at that kind of winner-take-all competition between the color and shape nodes. When one of them pops into that attractor state where it goes above threshold and starts recurrently activating, right, and robustly suppresses the other, we would call that an attractor state. And we think there are dramatic changes in the attractor state that frontal system's getting into in early development, right? And then the coupling between the posterior and frontal systems, there's also interesting dynamics going on back and forth there, that the system starts to pull itself almost up by its own bootstraps into this new state that it has never achieved before. Now that state might only initially last for, a couple hundred milliseconds. But the first time it occurs, it's new, it's never been there, qualitatively new attractor state. And one of the things that development, I think, in learning is all about is getting into the, discovering that newest state that it's never been into before, and then learning how to get back there over and over and over again. And that's what we call skill acquisition.
Well, I can imagine, the rotating switch. These are continuous dimensions in your model. Mm-hmm. And so I'm wondering at what point, is it arbitrary when you call it a new...
I don't think it's arbitrary, because we can define what those states are, but you're right that we can get into and out of those states through quantitative change. So I think we can define what qualitative means very precisely, and we can also define how qualitative states are related to quantitative change very precisely. And that, in part what we argued in that paper was that's kind of what the field needs is sort of clear, crisper definitions of these terms that we use a lot, right, for historical reasons. Last question? Okay. Yeah.
Do you think that if you change the location of the targets, it would within the condition, so the color one is red and fair and do you think that you would see new growth flexibility there, or do you think it would be
If we kind of think about the standard version and we are swapping those cards in space, that should then, you'd think it would spread out the activation traces in both of the dimensions. And yeah, it's possible if you smear it out enough that you can get kind of a condition where 3-year-olds could succeed.
Thank you.
Yep.
Any answer?